So this is the PSAT Paper Practice Test, Module 2, Section 2. If you are looking for Section 1, that is a separate video. Link is down below. Calculators are allowed on this section. Problem number 1. The box plot summarizes 15 data values. What is the median of this data set? They are just testing your knowledge of box plots. So if I have a box plot, it's going to look something like this. There's going to be a line somewhere in the middle of it. In a box plot, and let's not have pink, let's have orange. Why not? This area here inside the box represents 50% of the data. This line here in the middle of the box represents the median, and this is the minimum and maximum of the data. So they want to know what is the median of the data set, and here it is. It is 5. C is my answer. Number 2, what is the x-intercept of the graph shown? On the xy plane, if I have a line or a parabola or anything else that's going around, the x-intercept is where it crosses or touches the x-axis. So they want you to look at this graph, look at this parabola, and notice this is the x-axis and go, where is it touching or crossing the x-axis? That is that point right here. When we're writing coordinates, we write the x value first. So it is 4, 0. It is 4 over, but it does not go up. 4, 0 is that x-intercept, and that would be D is my answer. Number 3. Henry receives a $60 gift card to pay for movies online. He uses his gift card to buy 3 movies for $7.50 each. If he spends the rest of his gift card balance on renting movies for $1.50 each, how many movies can Henry rent? All right, so he's starting with 60, and his first expenditure is he buys 3 movies for $7.50 each. So 3 times $7.50 will tell us how much he spent. That would be $22.50. Since he spent $22.50, we want to know how much he has left to pay on renting movies. So 60 minus $22.50 is going to be $37.50. And then since these movies cost $1.50 each to rent, how many times does $1.50 go into $37.50? So $1.50 into $37.50. If you're doing this by hand, just as a little shortcut, I mean, you may choose to use your calculator, as you may on this portion. If you're doing this by hand, if you have 2 things you're dividing and they both end in 0, you can just drop those zeros, make it a little simpler. You will get the same answer. Move that decimal 1 over. 15 into 3 doesn't go anytime, but it does go into 37 2 times. 2 times 15 is 30. We subtract, we get 7, bring down our 5. 15 into 75 is 5. So 25 is our answer. Now this is one of those cases also where if you're looking at the choices, if you start this division, as soon as you say 15 goes into 37 2 times, you know your answer because there's only one answer that begins with 2. We have 10, 25, 35, and 40. So as soon as you get that 2, you know it's 25. But if the answers had been different, it's good to know how to divide. Again, if you choose to do that by a calculator, that's fine. You are allowed to do so. Number 4, x equals 49 and y equals the square root of x plus 9. The graphs of the given equations intersect at the point x, y in the xy plane. What is the value of x? Now, if you're curious as to what these 2 equations look like, keep in mind you do not need this information to solve this problem. But just to give you a visualization, that first x equals 49, that is going to be, and I am not drawing this to scale, that is going to be a vertical line where x is 49. So this is like all the way over, and this is 49. So that right there is x equals 49. And the square root of x plus 9, a square root, we just say the square root of x, that is like half of a parabola on its side. That starts at 0, 0, because here it says plus 9, that's on the outside. It's not in there with the x. that plus 9 on the outside will move this up 9. That's what the effect of a number on the outside does. It moves it directly. So if it's plus 9, it would go up 9. If it had been minus 2, it would have been down 2. Yeah, there's a whole set of rules for what numbers do about that. That is a topic for another video. But it's good to look into those sort of rules. So in this case, square root of x plus 9 is this kind of square root, but it's been moved up 9. So I've got this x equals 49, and then I've got this little square root of x plus 9, and it's going like that. And they're going to intersect. What is the point where they intersect? Again, this is a visualization. We don't really need it to solve this equation, but it can be helpful for some students to get that. So where do they intersect? Well, if x equals 49 at every single point on this line, all we need to do to find out where they intersect is to plug 49 into that equation. So y equals the square root of, and there's my x, I'm going to change that to 49, plus 9. The square root of 49 is 7, and 7 plus 9 is 16. So at the point of intersection, the x value is going to be 49 because it's always going to be 49. Because every point there, x equals 49, just is. And my y is going to be 16. So that's the coordinate, and they're asking what is the value of y? It would be 16. And they're actually playing nice. I'm shocked, honestly. I would have expected them to put 49 as one of the options there to be mean, but they didn't this time. So just our answer is A, 16. A cherry pitting machine pits 12 pounds of cherries in 3 minutes. At this rate, how many minutes does it take the machine to pit 96 pounds of cherries? There's a couple of ways to do this. You can set up a ratio, or you can just kind of like, I guess, feel your way through. It would be the best way. If I say, all right, there's 12 pounds of cherries every 3 minutes, and I need to get 96 pounds of cherries, and I don't know why I put inches there, and I don't know how many minutes it's going to be. So I would look at that and go, how many times does 12 go into 96, or 96 divided by 12? Because these are a direct sort of proportion. Well, 12 times 8 is 96. So to get from here to here, I multiplied by 8. So over here, I would do the same thing. 3 times 8, which would be 24, which would be C. If you want to set this up in a more proper sort of proportion, we would say that there are 12 pounds of cherries every 3 minutes. Then on the other side, I want to do the same thing. I want to do pounds to minutes, like that. And this ratio of 12 to 3 can be simplified because 3 goes into both of those. It goes into 12 4 times, and it goes into 3 1 time. So that same ratio. Now to solve this, we would need to cross multiply. I would say 1 times 96 is 96, and 4 times x is 4x. To solve for x, I would divide both sides by 4, and once again, we're going to get that x is equal to 24. So either way, if you just kind of do the, I guess, more kind of logic and just kind of thinking about it that way, or if you prefer the sort of structure of setting up a ratio and cross multiplying, both are 100% valid. Both will get you the right answer. On to number 6. If 2x equals 12, what is the value of 9x? So first we're going to solve for x, and then we're going to evaluate what 9x is. So if 2x equals 12, 2 times x, I need to do the opposite of that, or divide to solve for x. So I divide both sides by 2, and I get that x is equal to 12 divided by 2, or 6. Now I know what x is. To find the value of 9x, I would say 9 times x. Let's replace that x with 6. So 9 times 6 is 54, and that is my answer. Number 7. Line K is defined by y equals 1/4 x plus 1. Line J is parallel to line K in the xy plane. What is the slope of J? You don't have to graph for this. They're testing for 2 things. 1, how do the slopes of parallel lines relate to each other? And then 2, If I have an equation, y equals 1/4 x plus 1, how do I find the slope of that line? So first things first, if I draw a parallel line, and Microsoft is being glitchy, there it goes. Okay, so I have these two lines. They are parallel. They do not cross. They would just go on and on and on forever. They have identical slopes. That's what they want you to know. All parallel lines have the same slope as each other. Not all parallel lines have the same slope. Like, it's not like all parallel lines are going to have a slope of 3/2. No, it's saying that if this line has a slope of 3/2, I don't know if it does, I'm just picking a random number. If it did, then this line that's parallel to it would have that same slope of 3/2. So, okay, I know, since it says that line J is parallel to line K, that whatever slope line K has, line J will also have. So I need to look at this equation they provided and say, what is the slope? Well, when lines are in this arrangement, y equals mx plus b, where x and y are variables and m and b are constants or plain numbers, then things are really nice and simple. And lo and behold, that's what they've given us. 1/4 would be my m and 1 would be my b. B, this number that's out on the end, is always going to be the y-intercept. And this m, the number that's attached to the x, is our slope. So right there in this equation they've given us, the number attached to x, 1/4, is the slope of line K. And since line J and line K are parallel, the slope of J is 1/4, or 1/4. Number 8, which of the following lists represents a data set that has the same median as the data set shown? The median in a list of numbers is the number that is right smack dab in the middle. And I don't mean looking at 6 and 21 and saying, what's the number that's middle in between 6 and 21? What I'm saying is, how many numbers are there? Which number is the middle number, like sort of physically, spatially placed here? What you're going to do is you're going to count how many numbers there are in the data set. 1, 2, 3, 4, 5, 6, 7. This is an odd number. So 7, if I were to say, what's the number right smack dab in the middle? There would be 3 on either side and then 1 in the middle. So you're going to, if it's odd, you're going to divide it by 2. So 7 divided by 2 is 3.5. So you know there's going to be 3 on either side, and then the number in the middle is the one that you want. If you were given this and it had been an even set, like say if there were 4 numbers, I'm just going to go simple here. There's 4 numbers. You're like, wait, that would be 2 on either side, and there isn't a number in the middle. If that happens, if you were given an even number of values, you're going to take those 2 middle numbers and average them together, and that's going to be your median. So in this case, since there are 7, we go, let's see, 1, 2, 3, there's that number in the middle. And you see there are 3 numbers on each side. That number right smack dab in the middle is 8. So the median of that first one is 8. Now down here, I have a bunch of lists, and I'm going to see what the middle number is. So here I have 1, 2, 3, 4, 5, 6. That's an even number. So I'm going to take the 2 middle numbers and average them. The median of this is 6. That is not the same. Look at this one, B. I have 1, 2, 3, 4, 5, 6 again. So I'm going to take those, it's an even number of values. I'll take the 2 middle numbers. They are both 8. Average them together, 8. Looks like B is our answer, but I always like to check the others just to make sure I'm doing things correctly. I have 1, 2, 3, 4, 5, 6 values. We would take the 2 middle ones, 10 and 10, averaged together is 10. And then 1, 2, 3, 4, 5, 6. Again, we take the 2 middle ones because it's an even. 10 and 10 is 10. Confirmed. B is our answer. It has the same median of 8. On to number 9. The length of the base of a certain parallelogram is 89% of the height of the parallelogram. Which expression represents the length of the base of the parallelogram where h is the height of the parallelogram? I always will draw. If they talk about shapes or anything like that, I'm drawing the instant I see it's a parallelogram. Okay, so I have a base and I have a height. It says the length of the base is 89% of the height. So it is less than. The height is the whole and the base is 89% of that. the way we say 89% of something, we would multiply it by 89%. So if I took that height and multiplied it by 89%, I would get the base. That would be representing the base being 89% of the height. The other way that 89% can be represented is as a decimal of 0.89. So the height times 0.89 would equal the base. So I'm going to write that as 0.89 times the height is the base. Now it's asking which expression represents the length of the base. Okay, I've already said it's 0.89h, so let's look at our choices, and there it is, 0.89h. D is my answer. Number 10, for a camping trip, a group bought X 1-liter bottles and Y 3-liter bottles for a total of 240 liters of water. Which equation represents the situation? If you look, they all are set as equal to 240. So we're not talking about the number of bottles, but just how many liters of water. So if I was talking number of bottles, that would just be X plus Y. X is how many 1 liters and Y is how many 2 liters, or 3 liters, excuse me. But that would not equal 240. I don't know how many water bottles they brought right now. So this one right here where it says X plus Y equals 240, that is not accurate. That is not what we want. Now look at our other options. It's always good to look at your answers on these. So what's happening here? Here it's saying we're multiplying the X by nothing or by 1 and the Y by 3, and it gets us our total. That seems pretty logical, but let's look at our other two just to make sure that we're on the right track with A. Here it's 3 times X and 3 times Y would equal a total of 240 liters. Well, that's not true because the X is only 1 liter. Why would I be multiplying the X by 3? That's not the option. And then our last one is multiplying the X by 3 and the Y by nothing, and that would get 240 liters. No, the X is only 1 liter each. The Y is 3 liters each. So if I want the total number, I need to multiply that Y by 3, and together they will equal 240. Confirmed, A is my answer. On to 11, Y equals negative 4X plus 40. Which table gives 3 values of X and their corresponding values of Y for the given equation? All right, so again, this is one of those, they want you to look at the answers and say which answer is best. Now, if I notice every single one of these starts with 0 and then has 1 and 2. 0 is going to be a really easy number to plug in here, so that's where I'm starting. I'm going to plug 0 in, and that should eliminate some of these options right off the bat. So if I plug 0 in, whoops, still erasing. There we go. If I plug 0 in for X, I get negative 4 times 0, or 0 plus 40 is equal to Y. So 0 plus 40 is 40. So when X is 0, Y is 40. And right off the bat, A is out and D is out because both of them say that when X is 0, Y would be 0. That's not true. So now all I have to look at is B and C. So I'm going to move on to what happens if I put in 1 for X. So let's try that. Let's plug in 1. Y equals negative 4X plus 40. And I'm going to replace that X with 1. So negative 4 times 1 is negative 4 plus 40. Negative 4 plus 40 is 36. So when X is 1, Y is 36. And sure enough, C has that option, B doesn't. So I don't even have to go on to test number 2. I already know C is my answer. Number 12, the shaded region shown represents solutions to an inequality. Which ordered pair is a solution to this inequality? If you have an inequality, the solutions are every single solitary pair of ordered pairs that is in this shaded area, and if it is a solid line, every pair of ordered pairs on the line. If this is a dotted or dashed line, if you see that, then it would only be those in the shaded area, but that's not the case here. This one, it is a solid line and a shaded area, so these ordered pairs that are on the line or in the shaded area are my solutions. So what they want you to do is look at these 4 options. Again, we're looking at the answers and seeing which one works. and saying which of these is either in the shaded area or on that line. So let's go through them. 0, -4. When x is 0 and y is -4, that's right there. That is not in the shaded area. All right, so next one. 0, 4. When x is 0 and y is 4, we go up here. Nope, that is not in there either. Next one, -4, 0. And we go to the left, -4, and we stay on 0. Nope, that is not there either. Last one, it better be in there. 1, 2, 3, 4, and 0. Ah, there we are. 4, 0 is in the shaded area, so it is a solution. 12. In triangle JKL, in the instant they say triangle JKL, I'm drawing a triangle. All right, so I have J, K, and L. Okay. The measures of angle K and angle L are each 48 degrees. Okay, so angle K is 48 degrees and angle L is 48 degrees. What is the measure of J in degrees? Disregard the degree symbol when entering your answer. They are testing whether you know that the three angles of a triangle, any triangle, when added up, equal 180 degrees. So in this case, angle J plus angle L plus angle K would equal 180. They've told us that angle L is 48 and angle K is 48. So together they would equal 180. Now let's just solve for J. 48 plus 48 is 96. So J plus 96 equals 180. And now I'm going to zoom out a little bit because I'm running out of room. To get this J by itself, I want to undo this adding 96. So I'm going to subtract 96 from both sides. And I'm left with J on the left and 84 on the right. So 84 degrees is my answer. 14. Y equals x squared plus 14x plus 8. X plus 8 equals 11. The solution to the given system of equations is xy. What is the value of y? All right, let's look at the more simplistic of the two equations first. X plus 8 equals 11. There's only one variable, so I can solve for x. I'm going to undo this adding of 8 by subtracting 8 from both sides. So x plus 8 minus 8, just x by itself is left. And on the right, 11 minus 8 is 3. So I know x equals 3 is the same as this, and that is a vertical line. X equals 3 is a vertical line. Now this, the x squared is a parabola. So I've got a parabola, and somewhere else I've also got a vertical line, and they're crossing at a single point, and they want to know where that point is. That's what we say when we mean a solution to a system of equations, is where do these two equations, if we graph them, where do they cross? Where do they intersect? Okay, so I know x equals 3 is 1. So all I need to do to find this point of intersection is to take my other equation and plug 3 in wherever there's an x. So I'm starting with y equals x squared plus 14x plus 48. And let's plug 3 in wherever there's an x. So that's going to be 3 squared plus 14 times 3 plus 48. Okay, so now it's just just doing our math here. 3 squared is 9. 14 times 3 is 42 plus 48. And again, they allow calculators. So if you want to do this in a calculator, you can. 42 plus 48 is 90, and 90 plus 9 is 99. So that is our answer. All right, number 15. A cleaning service that cleans both offices and homes can clean at most 14 places per day. Which inequality represents this situation where F is the number of offices and H is the number of homes? All right, so F is our number of offices and H is the number of homes, and together they can clean at most 14 places per day. So together, or adding them, has to be at most 14. And there, look at our options here. We have F plus H, F plus H, F minus H, F minus H. And right off the bat, F minus H, F minus H, those are off. Those are out of the question, because we're saying together, we're adding, we're bringing them together. So it's either going to be less than or equal to or greater than or equal to. Well, it's saying at most 14 places a day. Does that mean they could clean 20? No, 14 is the most. That is, they can do 14, but no more than 14. It would have to be less than or equal to 14. So A is my answer. 16. Which expression is a factor of 2x squared plus 38x plus 10? So they're not asking us to do like what we normally see with quadratic factoring, where you have an x plus times x minus, that kind of binomials. They're not asking for that. They're just asking for a greatest common factor of these three terms. Now this has an x squared, this has an x, but this doesn't have an x. The 10 does not have a variable, so I cannot pull out an x. So right off the bat, honestly, B, C, and D are out because they're saying, can you pull out an x? And you can't. So just by process of elimination, A would be the right answer, but let's just look at this as if we didn't have those answers in front of us. So if you were given a problem on the real PSAT where it's not super easy to kind of go, hey, I can't pull out an x, so those are all gone. Woohoo, I'm done. What you would look for in this case is you look for a number that goes into all three, or a variable that goes into all three, or both. And we've already established there isn't a variable that goes into all three, but 2, 38, and 10, they are all even, so I can pull out a 2 out of all of those. So 2 goes into 2x squared 2 times, so just listen, x squared is left, we divide it by 2. 38x, when we pull out a 2, 19x is left, and 10, when you divide by 2, 5 is left. 2 is a factor. My answer is A, which is 2. 17. The equation 40x plus 20y equals 160 represents the number of sweaters, x, and the number of shirts, y, that Yesenia, interesting name, purchased for $160. I hope I'm saying it right. If Yesenia purchased 2 sweaters, how many shirts did she purchase? Okay, so we're already given the equation. We don't have to figure it out. 40x plus 20y equals 160. So she spent $160 on sweaters. Girl likes her sweaters. So X is our sweaters, excuse me. She spent that much on sweaters and shirts. I'm sorry, Yesenia. Sweaters and shirts. Okay. Sweaters and shirts. So she purchased 2 sweaters. So they're telling us that this X is 2. So I'm going to do that. I'm going to replace this X with 2. But we still don't know how many shirts. And that's what they're asking us to solve. How many shirts did she purchase? Well, by them telling us how many sweaters, we've eliminated that variable. Now there's only one variable, and this will be very straightforward, and we can solve it. So let's do just that. First, I have that 40 times 2, that is 80. So 80 plus 20y equals 160. Now let's undo this 80 being added. We're going to subtract it from both sides. So on the left, I just have the 20y. On the right, 160 minus 80 is 80. Zoom out a little bit. Now to undo this 20 times y, I'm going to divide both sides by y. And I get on the left y, and on the right, 80 divided by 20 is 4. So Yesenia, again, I really hope that's how we're saying her name, purchased 4 shirts. 18. Y equals 0.25x squared minus 7.5x plus 90.25. The equation gives the estimated stock price Y in dollars. Okay, I'm going to write this over here because there's a lot of text going on, and I don't want to, get confused when I have these word problems. So I'm going to say Y is the stock price. Okay. All right, so I'm going to remember that. Y is the stock price. In dollars for a certain company, X days after a new product launched. Okay, so X is the number of days after a product. Okay. All right, so now I can remember that. Let me go forward. And X is greater than 0, greater than or equal to 0, but less than or equal to 20. So the first 20 days after a product was released, and Y is the stock price. Which statement is the best interpretation of X comma Y equals 1 comma 83 in this context? Well, before we read all their explanations, I want to decide what this means first, and then we'll see what matches the best. So they're saying X, Y, in this one case, is equal to 183. Now we are told up here, and I wrote down, saying that X is the number of days after a product was released. So this is my X value. So I can say, okay, so 1 day after the product was released, Y was 83. Well, what was Y? We're told Y is the stock price. So I'm going to say, okay, so 1 day after the product released, the stock price is $83. So that's what I think it means. Now let's read their 4 options and see which option best matches that. A, the company's estimated stock price increased $83 every day after the new product launched. Well, we don't know that. This is just telling us that 1 day after the stock price was 83. We didn't even do the math to find out what the stock price was when it started. So I doubt that stock price was 0. I don't think it rose $83, but we can't say either way definitively because we haven't done that math. But no, that's not what we've decided this means. B, the company's estimated stock price increased $1 every 83 days after the new product launched. Again, no, we haven't looked at the previous day or the next day. And another thing too that makes both of these answers wrong is increasing $83 every day, increasing $1 every day. Those are linear increases. That is something that's going up in a straight line. $83 every day, $1 every day. This equation that they gave us had an x squared in it. X squareds are exponentials. They are parabolas. In this case, it would just be one side of the parabola that we'd be looking at, the right side starting at 0. But that is not a steady straight increase. That increase is going to go whoop more with time. So A and B, just for that reason alone, are out. C, 1 day after the new product launched, the company's estimated stock price is $83. That is bang on what we said. C looks like our answer, but let's double check D just to be sure. 83 days after the new product launched, the company's estimated stock price is $1. No, we said the X is days. It's 1 day after the stock is 83. C is our answer. Number 19, f of x equals 39. For the given linear function f, which table gives 3 values of x and their corresponding values of f of x? Honestly, this does not seem like a number 19 level question. It seems like something that should have been much earlier, and that in itself can be confusing to students because you almost question, like, am I missing something? But you're not. It really is a sort of oddball. And trust me, there are some difficult ones coming, but they're almost like kind of messing with you by making it a more lower level introductory function question. And it's just, I don't know, I find it kind of funny that they're being mean by giving you a relatively easier question later in the game. But let's just look at it. F of x equals 39. So when f of x equals 39, when we say f of x, it means if I plug in a number for x, what will I get? You can replace it with y when you're graphing. Because that's what they're saying. You plug a number in x, what is the output? F of x, that is your output. What do you get? What is your y value that you get? Same kind of way of helping you look at it. So, okay, so if f of x equals 39, it means no matter what x I put in, it's going to spit out 39 as my y value if I'm graphing it. So whatever I put in for x, it doesn't matter. Any number in the universe that I put in for x, my y value is going to be 39. F of x is going to be 39. Well, let's look over here at our options and see which one of those represents that. This one says, whatever value of x I put in, I get 0. Nope. B says, whatever number of x I put in, I get 39. Ding, ding, ding. Let's look at C and D just to double check. X says, depending on what I put in for 0, I get different values, multiples of 39. Nope. And same kind of thing here. I'm adding 39 or subtracting 39 each time. Nope. It's that straightforward, honestly. F of x equals 39 means whatever number in the universe you plug in for x, you get 39 as your value for f of x or y, and that is B. Again, if you are familiar with functions and what they mean, then this is a very straightforward problem that doesn't require any calculations, and it's very strange to see it at number 19, and it can throw you off because you're almost like, wait, am I missing something? Shouldn't I be doing some math? No, not at all. All right, number 20, a triangular prism. All right, anytime I see a shape, I always draw it. And it's not a great triangular prism, but gets the point across, right? Hopefully. Okay. A triangular prism has a height of 8 centimeters, okay? And a volume of 216 centimeters cubed. What is the area in centimeters squared of the base of the prisms? They're asking, what is the area of that base? And then they're really nice here. And they tell us right here, it's not even at the beginning where we have to flip back, just right here. The volume of a triangular prism is equal to area of the base times height. Okay, so this is just a plug and play. So when I wrote area down here, they're saying B is the area of the base. So I'm going to say, okay, I'm looking for the capital B area of the base. Well, if volume is equal to area of the base times the height, we are told the volume is 216. So I'm going to replace that volume with 216. And I'm trying to solve for the base. Do I know the height? I sure do. I was told the height is 8. So I'm going to replace that height with 8. So 216 is B times 8. So to solve for B, I need to undo this times 8 by dividing by 8. So when I divide both sides by 8, 8 goes into 16, and it goes into 216 27 times. And, if you're a little math geek like me and like to do math like that in your head, go for it. But if you want to use your calculator, because you are allowed to use calculators in this section, go for that too. So B, the area of the base, is 27. That is your answer. Number 21, the graph shows the momentum y in Newton seconds of an object x seconds after the object started moving, for 0 is less than or equal to x, which is less than or equal to 8. What is the average rate of change in Newton seconds per second in the momentum of the object from x equals 2 to x equals 6? Average rate of change is slope. That's what it means. So this is simpler than it seems. And they're even telling you it's in Newton seconds per second. So, okay, there's my y values, Newton seconds per second. Those are my x values. So the y values over the x values. The change in y over change in x, slope. So even if that average rate of change didn't trigger that memory in your mind of saying it's slope, hopefully when they're saying Newton seconds per second, so y's per x's, y's divided by x's, hopefully that will get you thinking on the test day like, are they meaning slope? Yes, slope is average rate of change. So let's look at what the values are when x equals 2 and x equals 6. Well, when x equals 2, that value is 2, 6, those coordinates, that ordered pair. And when x is 6, it is 6, 8. So what would the slope of a line be connecting those 2 points? Well, it's change in y over change in x. So you subtract the y's on top and you subtract the x's on the bottom. So I'm going to start with the top one and then go to the bottom one. And I need to do that for both. So first I'm starting with that 6 and I'm subtracting the 8. On the other one, I'm starting with the 2 and I'm subtracting the 6. It doesn't matter which direction I go. I also could have started with the 8 and subtracted the 6 on top and then had 6 minus 2 on the bottom. You will get the same answer either way. Just make sure you're going in the same direction. Either 6 minus 8, 2 minus 6, or 8 minus 6, 6 minus 2. All right, so here 6 minus 8 is -2 and 2 minus 6 is -4. -2 over -4 simplifies to 1/2. That is my slope, and that is my average rate of change between those 2 points. Number 22, -15x plus 25y equals 65. One of the two equations in a system of linear equations is given. The system has infinitely many solutions. Which of the following could be the second equation in the system? When you have a system of equations, of linear equations, they're saying 2 lines. That I have 2, come here, there we go. It doesn't want to draw all of a sudden. There we go. I have 2 lines. generally speaking, when they say the solution of it, it's usually a single point where those two lines cross. There are only two other options. You can have parallel lines. There are no solutions. They never cross. Or you can have lines that are on top of each other. They're the same line. So that is when you have infinitely many solutions, when they are exactly the same line. So I have this line, negative 15x plus 25y equals a positive 65. And yes, I'm emphasizing those signs because it's going to be important in a second. Now, which of the following could be the second equation in this system? Now, if you notice, because again, they're asking us to look at these options and say which one is the best, which one could be the same line. Same lines are, you can achieve them by, or confirm that they're the same line. If I took each of these and I multiplied them all by the same number or divided them all by the same number, I would get a line that is the same. For example, 15, 25, and 65 are all divisible by 5. So I could divide all of these by 5, and I would get negative 3x plus 5y equals 13. Those two lines are the same. If I drew them, they would draw right on top of each other because I divided each of those by 5 to get there. Okay, so that's one method. But we don't really have to go trying and seeing if all of these work, like 12, 20, 52. They're not giving us any different numbers, so we don't have to do this test to figure out, how the numbers should line up. We know it's going to be 12, 20, and 52 because all four answers use 12, 20, and 52. But there is one small difference, and it has to do with the signs. So look what's going on here. Here we got positive, 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 and positive, positive, negative, negative, positive, positive, negative, positive, negative. That's the only difference. The numbers are the same, so I don't have to worry about the numbers. They've taken that part of the equation out of it. So now I just have to make sure that the signs would match. Okay, so negative 15x, so that needs to be a negative. Positive 25, that needs to be a positive. Positive 65, so that needs to be a positive. Negative 12x plus 20y equals 52, and that is C. There's my answer. So there's really no calculation or math required on this one because they did that for you by telling you 12, 20, 52 are the three numbers. Just check those signs. They have to be the same as the original, and that's your answer. Number 23. A bus traveled on the highway and on local roads to complete a trip of 160 miles. Okay, so we got this little bus. He's traveling along. And he goes, let's say he goes on a highway, and then he goes on local roads. He goes on a highway, and then he goes on local roads. Let's call it local roads. All right, and this total trip, this whole thing was 160 miles. All right, and it took him 4 hours, okay? I'm just writing all this down because when you have these big word problems, I find it helps as it goes to start writing things down to help you keep things straight in your head. The bus traveled at an average speed of 55 miles per hour on the highway. Okay, so here it's going 55 miles per hour. And on the local roads, average speed of 25 miles per hour on the local roads, okay? If X is the time in hours, okay, so X equals hours, that the bus traveled on the highway, hours on highway, and Y is the time in hours that it traveled on local roads, which system of equations represents this situation? All right, so first off, before I even look at these options in detail, I'm going to look at them generally. And I see that each one of them has an equation that involves 25 and 55. They're being multiplied by X and Y. So, okay, there's my miles per hour coming in. And some of them are adding up to 4, and some are adding up to 160. Okay. And then I've got these X plus Y's. And 2 of them are equal to 4, and 2 of them are equal to 160. Okay, that seems the simpler of the two, so I'm going to start with that, X plus Y. What would X plus Y equal? X said it's the hours on the highway. Y said the hours on the local roads. So together, the total hours that bus drove was 4 hours. So the hours on the highway plus the hours on the local road would be 4 hours total. That bus did not travel for 160 hours. It traveled for 160 miles. So, okay, so already I know the two that say x plus y equals 160 are out, so I can eliminate them. All right, now I'm left with the two that say x plus y equals 4. Okay, so I'm going to erase that x plus y equals 4 for just a second. Give me a little more room. Now, what are our two differences? This one says 55 times x plus 25 times y equals 160. This one says 25 times x plus 55 times y equals 160. All right, let's think about this. If I was traveling 60 miles per hour and I traveled for 1 hour, how far did I travel? 60 miles every hour times 1 hour, 60 hours. 60 miles, excuse me. What if I traveled for 2 hours? 60 miles per hour and for every hour, and I traveled 2 hours? That would be 120. This is a representation of the formula distance equals rate times time. There's our distance, there's our rate, there's our time. There's our distance, there's our rate, there's our time. There's a ton of variations on this problem. I can't go over all of them. I can only go over the one that's right in front of me. So distance equals rate times time. So this equation up here, these two variations, they're saying they add up to 160, the total distance. So I'm going to have a rate times a time, and then a second rate times a time, and together equals that total distance of 160. So let's look at them. On the highway was 55 miles per hour, and it was X hours. So, okay, so my first one, the rate was 55 miles per hour, and my time was X hours. I don't need a little time symbol. 55 times X. So that's how many miles were traveled on the highway. Then the rate times the time. What was the rate on the local roads? The rate on the local roads was 25 miles per hour, and the time on the local roads was Y hours. And there we go. 55x plus 25y equals 160. So B is my answer. Quadrilateral PQRS prime is similar to quadrilateral PQRS, where P, Q, R, and S correspond to P prime, Q, R, and S prime, respectively. Now, I'm going to draw, before I go any further, before I get into what these angles are, I am just going to draw a quadrilateral. I know it's not going to be right. It's not going to be to scale, but it's going to help me visualize what's going on here. And that's an awful one. Let's go. Do something like this. I don't know if that is anything like it. The odds are not in my favor. It looks like it's going to be very different from what the actual quadrilateral is, but I'm just doing this so that I can have a nice point of reference for it. So I am going to label this as my prime 1, P prime, Q prime, R prime, S prime. It's hard to say. And then it's similar to another quadrilateral, so I'm going to try to draw like a little, I'm going to guess smaller, I don't know yet, a smaller version, scaled up or down. In this case, I'm guessing scaled down, but I don't know yet because I haven't read the rest of the problem. And that's PQRS. Now, similar figures are scale versions of each other. So you could scale up or scale down, make it bigger or smaller, and they would line up perfectly on top of each other. The other thing to know about them is that their angles, their corresponding angles, are always congruent. So let's go and see what information they're giving us with that in mind. Next sentence says, the measure of angle P is 30 degrees. Okay. Angle P here is 30 degrees. Well, the corresponding angle, P prime, is 30 degrees then. Corresponding angles are congruent. Next information, the measure of angle Q is 50. All right, so 50. Angle Q is 50, and Q prime would be 50. And the measure of angle R is 70. Okay, 70. R prime would be 70. The length of each side of the P prime, Q prime, etc. is 3 times the length of each corresponding side of PQRS. So I'm going to say, represent that on my picture by saying, okay, well, if this side were X, this side over here, p prime to q prime, would be 3 times as big, or 3x. Okay, so now I have a nice visual representation of all the information they've given me. Let's look at the question we're being asked after all that. What is the measure of angle p prime? Now, if you were like me when you read this, you're probably expecting them to have you figure out what s prime is, or figure out the lengths of one of these sides or something. And no, really, all they're asking is the measure of angle p prime, it's right here, which we determined way back up here that it was 30 degrees. So literally all this other information is extraneous and doesn't matter at all. But they're testing that you can kind of pierce through all of that verbiage and find that one critical piece of information. Since P is 30, then the corresponding angle of P prime would also be 30. B is my answer. 25. F of x equals 2x plus 244. The given function f represents the perimeter in centimeters of a rectangle with a length of x centimeters and a fixed width. So a number, no variable involved. What is the width in centimeters of the rectangle? Okay, so I'm just going to draw a rectangle. I don't know if I'm drawing it to scale. All right. So I know that x is the length. Okay, I'm going to put x on both sides there. And the width, we don't know what it is. I'm going to put a question mark. Don't know what that is. All right. So, and I could use another variable, but I don't know. I feel like putting a question mark there instead of a y or z or something. So if I was going to find the perimeter of this rectangle, I would add up all 4 sides. So I would add x plus these 2 unknown sides. So it would be 2 x's, 2 times x, x plus x, and then there would be 2 of these unknown lengths. And if I add all those together, I get the perimeter. Now we're told this function up here represents the perimeter. Doesn't that look an awful lot like this? I've got my 2x right there, and then I've got this number sticking out here. So it's exactly the same. So I can take this and put it over on this side. So 2x plus 2 times our mystery 1. And honestly, I should stop calling it that. I should call it W for width, shouldn't I? Yes, I should. That would be professional. We want to be professional here, right? So 2x plus 2 times the width would be the perimeter. And we're told the perimeter is also 2x plus 244. Those x's, those 2 x's are going to cancel out. I can show you that by saying if I subtract 2x from the left, I need to subtract 2x from the right. And now they're both gone on both sides. And I am left with 2w equals 244. To solve for w, I need to divide both sides by 2. And I get that w is equal to 122. And that's it. B is my answer. Number 26. All right, the last 2 on these, they're kind of, they up the difficulty on these, especially number 27, but 26 definitely is a jump up as well. The functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? And we have these 2 functions. We have f of x, which is 33 times 0.4 to the power of x plus 3. Then g of x, which is 33 times 0.16 times 0.4 to the power of x minus 2. Okay, I really recommend using your graphing calculator on this one. We have this exponential, we have this function with this, the x should say the x is in the exponent, be the more accurate way of saying that. And just to give you an idea of what you're doing and what you're looking at. Because when you have something that's to a power of x, and you've also got these 0.4s, which are fractions, essentially it's 2/5. It's better to get a graphing calculator so you know what you're dealing with. If you have a basic function where x is in the exponent, like say 2 to the power of x, it's going to look something like this. You have where it's approaching 0 going left, and it's going up into the sky going right. But when you start adding different things in the exponent and you start adding fractions in the base, it can be a little tricky to know with certainty whether this is a function where it is going like this, or if it's a function that's going like this. And you have the graphing calculator there. Don't guess, just use the graphing calculator, either your own or Desmos. In this case, because of those fractions, that 0.4 that's in the base, they're both going like this. They're a little different. They're a little, I'm not drawing this correctly at all. I'm trying. It's very hard on the screen. And I am not drawing this to scale. I'm really not. I'm just giving you an overall idea of what it's going to look like. So once you see this in the graphing calculator, you put both of these in and be very careful. This is one little tip I'm going to give you on this. Be very careful with when you're inputting things into a graphing calculator to make sure that it fully understands that, like say, this x plus 3 attaches only to the 0.4. Because I don't know whether you're going to be using your own graphing calculator or Desmos. But Desmos, it's pretty, it's pretty clear. You can actually see it going exponential. Some graphing calculators, they make you use that little caret to say the exponential. If that is the case, if you're having to write it out like 33 times 0.4, you do the little caret x plus 3, just as a little side hint to make sure you don't enter it incorrectly. If you want to be extra careful, if you don't trust your calculator, put a parentheses around that x plus 3 and then put another parentheses around all that. So it knows that is all together and the 33 is by itself. That's just a little calculator tip for you because, yeah, don't want to mess up and get a question wrong just because of some typing and then the graphing calculator not understanding what you need. We don't want that to happen. Okay, so you've typed these things into your graphing calculator and you got a graph that looks somewhat like this, so you know the shape of these two things. Now, let's go back and read the question again. What do they want us to know? They say it's where x is greater than or equal to 0. Okay, so part of this graph doesn't count. Anything where x is less than 0, all this area here, the negative, I'm trying to get as close as possible. All this negative doesn't matter to this question. Okay, so that we know right there. All right. Then it says, where x is greater than or equal to 0, which of the following equations displays as a constant or coefficient the maximum value of the function it defines? Let's look at that second part first, the maximum value of the function. Both of these functions that we've got here, they're starting on the y-axis, and then they are going down towards that x-axis. They are approaching it. They are approaching 0. They're never crossing it, but they're getting lower and lower and lower forever. So where is the maximum value for both of these? For both of them, it's where x is 0, right on that y-intercept. Every other value is going to be lower than that. Those are the maximums. So at this point, before we go any further, we need to determine the maximum value of both of those. Now, if you have a graphing calculator, you can go over here and like really zoom in and see if you can figure out what the values are at those 2 points. If you can do that accurately and you can get a 0 and you can find out what the y value is at both of those, if you can do that accurately, that's great. Absolutely, that is great. Another way to do it, which is, absolute, is to put 0, since we know x is 0 at this place, is we can put 0 into both of these equations and see what we get. Either way works. If you can zoom in enough and very accurately say what is the value of y when x is 0, that works. I'm also going to show you the way when you plug in 0 in these two, what you get. So, okay, first one, f of x, 33 times 0.4 to the power of x plus 3. So when x is 0, that's just going to be 33 times 0.4 to the power of 3, right? To the power of 3. And if we do that math, if we do 0.4 to the power of 3 times 33, then we will get 2.112. All right, remember that. We're going to come back to it in a second. All right, second one, I'm going to plug in 0. 33 times 0.16 times 0.4 to the power of x minus 2. Okay, and I should have written that. I should have written that down lower. Shame on me. Clearly that was poor planning on my part. So let's redo that. 33 times 0.16 times 0.4 to the power of x minus 2. All right, and we want x to be 0, so 0 minus 2 is just negative 2. All right, so what happens when we do that math? If you didn't have a calculator, frankly, this is one I think it's almost easier just to do it without a calculator. 0.4 to the power of negative 2. Anytime it's to the power of a negative, it means 1 over that. So 1 over 0.4 squared. 0.4 times 0.4 is just 4 times 4, or 16. And then you go, all right, there's 2 decimal places, 0.16. Me, because I do math so often, I'm doing math all day, obviously, with this YouTube channel and tutoring and such. That's easier for me just to look at that and go, oh yeah, that's 0.16. I fully acknowledge that is not true for everyone. You have your calculator. If you need to use your calculator, go for it. It is there for you. All right, so we know that this is now 0.16. It doesn't want me to write. There we go, 0.16. So now I have 33 times 0.16 times 1 over 0.16. Those are going to cancel out. It's like 5 times 1/5, 6 times 1/6, 8 times 1/8. All of those are equal to 1. So 0.16 times 1 over 0.16 is equal to 1. So that all cancels out, just becomes 1. 33 is my answer when I do all that. Why doesn't it want me to? Right, there we go. All that equals just 33. Okay, now that we've done this math, let's go back and find out what exactly. It says, which of the following equations displays as a constant or coefficient the maximum value of the function? All right, what that means is this result that we got, 2.112, that is the maximum value there. 33, that's the maximum value there. If I go back and look at this original one, is 2.112 anywhere in there as a constant or coefficient in that equation? No, there is no 2.112 anywhere in that function. On to the second one, g of x. When I found the maximum of that one, when x is greater than or equal to 0, I got 33. Looking at that function, is 33 anywhere in there? Sure thing. There it is, 33. So it is not true for 1. It is true for number 2. So the answer is B, 2 only. Shoo-wee. Okay, 27. Guessing a lot of you jumped straight here. This one is a doozy. It is what I call a eureka problem. It's not a problem you're going to find in your math book. It's one you just kind of have to have a eureka moment and figure out what they're wanting you to do. Hopefully, some of the earlier problems weren't too time consuming, so you're able to give some more time and thought to this one, because I think it's going to need it. We start with 64x squared minus 16a plus 4b times x plus ab equals 0. In the given equation, a and b are positive constants. The sum of the solutions to the given equation is k times 4a plus b, where k is a constant. What is the value of k? Shoo-wee. Yeah, it always kind of shocks me how much the difficulty value goes up in these last few questions on the PSAT in particular. The SAT kind of has a gradual ramp up, but the PSAT just goes, all right, here's everything you've been preparing for, and then this, and they just blindside you with it. Let's get started tackling this monster. 64x squared minus, all in parentheses, 16a plus 4b times x plus ab equals 0. First things first, there is a greatest common factor here in this 16a plus 4b, and I'm going to take that out. So I'm going to write that in red. I'm going to take that out. 4 goes into everything in there. So the 64x squared stays the same, but I'm pulling out a 4, which leaves behind 4a plus b, because 4 times 4a is 16a, and then 4 times b is, oh, didn't quite draw it, 4 times b is 4b. That x stays out there. Then we have plus AB equals 0. Now I'm going to get rid of this 4. I'm going to divide everything here by 4. All 3 of these terms and then the 0. Okay, so that leaves me with 64x squared divided by 4 is 16x squared. That 4 cancels out that, so I am just left with 4a plus bx plus, and then I have, you can write this as just ab over 4. It's the same as 1/4 times ab. ab over 4, same difference. And then 0 divided by 4 is just 0. The reason that I did this, and this is why I call it a eureka moment, you have to go like, oh, is look at our goal. Are all these kind of problems where you can't really see the path, the goal is important. And here the goal is that the sum is going to be equal to k times 4a plus b. And if you look over here, 16a plus 4b, they want you to have that eureka moment of, wait a minute, those are both divisible by 4. And if I pull 4 out, I'm going to be left with 4a plus b. And that's also in the goal where I'm trying to get to. That has to mean something, right? Like I said, eureka moment, it's not going to be in your math book. So the next part of this sort of eureka thing you want to have is, if we're talking about the sum of the solutions to an equation, what would that look like for just any equation? What would the sum of solutions to any equation, any quadratic equation here, what would it look like? All right, for that, we're going to go to the quadratic formula. So that is normally written as, if I have the ax squared plus bx plus c, then it's negative b plus or minus square root, and it goes on from there. Just, that's how it's normally written. I'm going to use capital letters here because we've already got a lowercase a and b over there, and this is going to get really confusing really quickly. Don't know why they chose a and b, just to make it harder on you. So we're going to call this capital A x squared plus capital bx plus capital c. So the quadratic formula says it would be negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, that plus or minus represents the two answers. So one solution to any quadratic equation would be negative b plus square root of b squared minus 4ac all over 2a. And the other would be negative b minus square root of b squared minus 4ac all over 2a. So our goal, remember, is the sum of the solutions, adding them together. So let's do a generic for all quadratics. What would happen if I added together these two solutions? So first, our first solution would be negative b plus square root of b squared minus 4ac all over 2a. And then our second one is negative b minus square root of b squared minus 4ac all over 2a. And what would the sum of those be? Well, these are fractions. They have the same denominator, so we would keep the same denominator, and we're going to add the numerators together. So I'm going to reorder them first. I'm going to put those two negative b's together up front. So I have a negative b plus a negative b. And then I'm going to put these two on the back. First, I have the positive b squared minus 4ac. And then I have the negative square root of b squared minus 4ac. My handwriting is getting so bad. This has been a long recording session doing all these questions for this module. All right, so these two, even though they are complicated looking, they're going to cancel out. They are identical except one is positive and one is negative. So they cancel out, they're gone. Aren't you glad of that? I know I am. Like a plus 5 minus 5, plus a million minus a million, they cancel out. And what's left is negative b plus a negative b. Well, that's just a negative 2b over 2a. Well, I can get rid of those 2's. They cancel out. I am left with negative b over a. So what that is saying, that for any quadratic equation, if I find the solutions and then add them together, I will get a negative version of this middle coefficient divided by or over the first coefficient, negative b over a. Okay, so I'm going to erase all of this that we just used to solve that or to figure that out, that it's negative b over a, and I'm going to zoom back in. I'm going to go back up here, and I'm going to write sum is equal to negative b over a. And this is the big B, big A. So in this case, b would be negative 4 times a, negative 4a plus b. And my a would be 16. Okay, so the sum of the solutions is going to be equal to that. So let's plug those in and see what we get. All right, so negative b. Well, this b is a negative already, so a negative negative makes it a positive. So just 4a plus b on top. And the a on the bottom, there's my a, capital A. Remember why they picked a and b, just to make it confusing for the poor students. Like, let's have multiple a's and b's in the same problem on the last one that's already confusing. That's a great idea. All right, so again, that first capital A, that first coefficient is going to be 16. Now that is the sum of the solutions, but we were told up here that the sum of the solutions is k times 4a plus b. You're like, what? What? I'm so close. I'm so close. The one says divided by 16 and this says multiplied by k. Another way of dividing, you can say, is multiplying by 1 over that number. So if I want to say divided by 5, that is the same as multiplying times 1/5. So in this case, divided by 16 is the same as multiplying by 1/16. And praise be, that is our final. Woo-hoo! Okay, we are there. Thank goodness. There we have our 4a plus b and 4a plus b. Those are going to cancel out on either side if we divide by 4a plus b, and we are left with 1/16 equals k. And that is our answer. That's it. K is 1/16. Personally, frankly, I think that problem's kind of evil. Again, it is not a problem you are going to see in your math books. I can't imagine you're going to see anything like that in your math books. It really is just a eureka problem that I hope it's not even a multiple choice. So you can't even like try and test to figure it out that way. It really is. They're just testing if you have that sort of eureka moment and figure out a solution to this thing. And so I'm sorry you have to deal with that. But hey, at least you're done, right? You're done. Woohoo! If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.